Okay, so here we're going to look at a one sample mean t-test. This is for when sigma is unknown. So if you recall for the z-test, it typically would say the population standard deviation, or it would show sigma there. So this one is actually not going to show that. In fact, it doesn't even give us any of these other values. It gives us raw data here. And so from a sample, when we run a one var stat, typically all we could get is the sample mean and a sample standard deviation. So that's going to be one of the giveaways that this is going to be a t distribution here. Okay, so let's go ahead and do our 4 steps. So we're going to start off with the null and alternative, so our HO and HA. So there's the null and the alternative here. There we go. Okay, and our claim here is saying that it is larger than 1 in this case. So is there convincing evidence? And it's going to be right here. Is greater than 1. So that's going to be our claim. And I always like to denote it. When I fill it in, that's the first one I'm going to fill out. And I'm going to go ahead and write my little note that that's the claim there. Okay. And by default, we're going to go ahead and say that the null is equal to 1. Our second step, we're going to go ahead and get our stats and our data here. So X bar, and then the question is, are we doing sigma or S? And we've kind of talked about this a little bit already, where this is going to be an S because we're using a T distribution here. Our N and our alpha. So in this step, we kind of want to get all of our data. And the way we're going to get the sample mean and sample standard deviation is we're going to run a one var stats. And we're just going to put all of this into a list, and we're going to go ahead and run that. And when we do, we get about 1.04. And then our sample standard deviation is about 0.0659. Our sample size is 11, and then the alpha is 0.05 in this case. Our third step, let's go ahead and do our graph and our calculations here. And so we're talking averages in this case here of conductivity. But we could also talk about this in terms of t-scores. And so right in the middle is going to be, if we're talking the conductivity, is going to be 1, because that's kind of what we're comparing it to here. Right? But if we're talking t-scores, right smack in the middle is going to be 0. And so we want to make sure what we're looking for is our t critical value, our alpha, those two go together, and then our t-test statistic, and our p-value. And those two are going to end up going together. And we'll go ahead and using a t-test here, since sigma is not given. So we're going to go ahead and just run this in our calculator. We're going to go ahead and do a t-test, and I'll post a video on how to do that. But really the calculator is just going to spit that out, and it's going to give us 2.01, and it also gives you the p-value. We could do this by hand. We could go ahead and use a formula for our test statistic there and figure that out. But we're going to go a little bit heavy on the calculator. And we want to start shading in our alpha here. And that's going to be 0.05. Again, it's right-tailed because it's greater than. And so we know we're shading off to the right here, and that's our 0.05. And so then here is going to be our p-value. And so what we're doing first is we're comparing alpha with the p-value. Alpha is larger than our p-value, so it should have more area. And that's why your p-value is contained inside of alpha, because it's going to be smaller. So where exactly, we're not sure, but we know it's contained within there. So that marker is our t-test statistic, and this kind of cutoff right here, this line in the sand there, is going to be our critical value. Okay, so what we're trying to check here is we know the conductivity is 1. And from our sample, we know that we had something larger than 1, 1.04. But the question is that large enough to be statistically significant, right? So this is kind of our line in the sand there, where if we go beyond that, then we say, yeah, we are far enough where it makes a big difference. If we fall somewhere within here, yeah, we're bigger than it, but it's close enough where it's about the same. And that's what we're trying to figure out here. To get our critical value, we're going to do an inverse T, and this function is only available on the TI-84s. For the 83s, you're going to need to get a program from the math lab. And you want area to the left and then your degrees of freedom. And if you recall, your degrees of freedom are 1 less than the sample size there. Okay. And so my T critical value is going to be 1.81. My T-test statistic is 2.01. And it's a lot easier to compare the T-scores rather than the areas. And so that's why we tend to figure those out, because we could see which one falls to the right or the left of that. And so our average conductivity, this 104, corresponds to this T-score of 2.01. Okay, so there's kind of our full picture. And let's go to our discussion and our conclusion here. And so let's compare our p-value with alpha, since p-value is less. If the p-value is low, we can reject the null. And so we're going to reject the null here. That means we do not reject the alternative. And in this case, since the alternative is my claim, those are one and the same, we're going to go ahead and do not reject that. So we're going to say there is sufficient evidence to support the claim that the conductivity is larger than 1. And notice that I said we could support it because the alternative is the claim. If the claim is the null, we're never allowed to use the word support. We usually say there's not sufficient evidence to warrant a rejection, so something along those lines.